Alrighty, so let's get started on number 3. So for this one, we're just going to write the equation. It says, after 3 seconds, 1 point of a paddle, of a water wheel, okay? So that's just a wheel that rotates like through the water, brings the water up and brings it down. Reaches the maximum height 16 feet above the water's surface. The diameter of the wheel is 20 feet, and the wheel makes 1 complete revolution in every 12 seconds, okay? So if we imagine our water wheel, so here it is, okay? Here's the water. The things they've told me about this water wheel is that its maximum height here, okay, so from here to there, above, right, the surface of the water is 16 feet. They have also told me that my diameter, okay, is 20 feet. So what that tells me is that when I'm under the water, right, it goes under the water 4 feet, right, 4 feet below, okay? The other thing I see here is the wheel makes 1 complete revolution every 12 seconds. So if that's happening every 12 seconds, it starts here at 3 seconds, they said, at a maximum height. Okay, so this is our max, which is a key word, right? We've talked about before. So it's going to be at its max, then it's going to rotate. The height is decreasing, right, coming down. And then we hit our minimum, which would happen 4 feet below the water, which, when we're thinking about this, would be like -4, okay, which we'll graph in just a minute. Then the height is increasing, and then hits our maximum again, which means we're talking about a sinusoidal function, okay, because we're going to keep coming back and hitting the same points over and over because of the circular nature of this. All right, so if it goes around in 12 seconds and goes through the whole entire cycle, that's really telling me that if it's 1 revolution, then that means my period is 12 seconds, okay? So that's going to be on my x-axis, okay? So that's the amount of time it takes to finish 1 cycle. So if I sketch this to help me write the equation, okay, I'm going to start my graph not at 0, but at 3 seconds, because that's when they tell me it hits its max. So I'm going to have a 3 here. I'm going to hit a max of 16. Okay, label your axes. So this is seconds, right, in time. And then this is our height, right, in feet. All right, so I should see those labeled. Okay, then I know, right, from what we talked about here, that I should come down and hit a minimum at some point 4 feet below the water. So if this is a height of 16, wouldn't this have to go into the negatives because that's below the water? So we hit our minimum here at -4. Okay, so those are my boundary lines. Okay, now I'm gonna complete 1 full revolution, right, and hit my max again. All right, after 12 seconds, not at 12 seconds, okay? So this is at 3 seconds. So if I add 12, right, then this will happen at 15, okay? And if that's a full cycle, then this minimum had to happen in the middle. Well, the middle of 3 and 15, right, 12 divided by 2 would be 6. So this would be 6 plus 6, so this would happen at 9, okay? You only have to graph the mins and the maxes for me. I don't need the other points, okay? So usually we have 5 critical points. You don't need that for word problems, okay? Now, our goal is to write the equation. So we need A, B, C, and D, okay? So if you remember, the first thing we always do is we draw a midline in so we can find our A and our D. So if this difference is 20, because that's the difference between my min and my max, right? That's the diameter of my circle. If this is 20, I need a midline that splits that in half, right? That difference. So if I take half of that, that's going to be 10. So 10 below my upper boundary would give me a value of 6, which would also be, right, have a difference of 10 from the lower boundary and where my minimum is. So that means my A value is 10, okay? And then my D value is 6 because my midline exists at 6. Now we can graph our sinusoidal function, okay? And we can hopefully see that this is going to be cosine, okay? Because this happens, this starts, okay, right here at a value of 3, and it starts at our max. So if it starts at a max, we're going to have cosine, okay? So y equals cosine, 10 cosine, because that's our A. I'll find my B last, okay? I have a shift here because you can see I circled where my graph started, okay? And I didn't start at 0 seconds, right? I started at 3 seconds because of the shift here. So this is going to be x minus 3. And then plus, and then my D value is 6 because that's my midline. Then to find my B, right? So to find B, you're always going to take your period, right? And use that to find the B value. So 2 pi over B equals, and we said our period, our full rotation happens in 12 seconds. So if I cross multiply, I get 2 pi equals 12b, right? Divide by 12, and B is pi over 6. So that is the coefficient to this quantity, okay? And you can leave that in factored form. Now, I know I made a bigger deal of this when we did numbers 1 and 2. You have to put parentheses around this when you have your calculator. So I encourage you to start doing that, all right? So there should be parentheses around that whole entire expression, okay? Now, let's look at number 4, and then we're done, because number 5 we're going to do during our next lesson, all right? So there is a typo in number 4, so let's fix that. It says, as you stop at a traffic light, a pebble becomes wedged within your tire treads. When you start off, the distance of the pebble from the pavement, okay, varies sinusoidally with the distance, not you, but the pebble has traveled, okay? And I guess you too, but we're specifically looking at the rotations of the tire, so it's just much easier. This, I think, more accurately should say pebble, okay? The period, okay, of course, is something, right? Now, assume the diameter of the wheel is 25 inches, okay? So we're talking about the distance from the pavement, aka the height of the pebble, versus the distance it has traveled, okay? So now we're not talking about time, we're talking about distance, all right? So if you think about this pebble, right, and here's the wheel, okay, if it's getting stuck in this wheel, okay, so let's say the wheel looks like this, and here's your spokes, you know, all that good stuff. And again, your drawing doesn't have to be as beautiful as mine, as I always say. So there's my pebble, right? It gets stuck, and that's going to be at a height of 0, right? So this is a height equals 0, and it travels around here. So what would be the period, right? Not the time, but what would be its distance? Well, that would be its circumference, right? And we know circumference is pi d, right? So pi d, if my diameter is 25, then the period would be 25 pi, because that's the total distance it's going to travel, okay? So let's take a look here. So we have, okay, our graph here. Let's see what this looks like. Okay, so we have a starting point here. We're going to assume at 0 time, because you're at it hasn't gone anywhere, so we're at 0 time, okay? And then it goes all the way up here. It hits a maximum of 25, right? The height is 25 here, and I know that again because my diameter is 25, right, inches. Then I come back down, we're talking about our distance, right? So then it's going here, right? And then we're coming around to that, a height of 0. So here's my height. Then I hit a maximum height of 25, right? And then the total distance it has traveled at this point when it comes back to a height of 0 happens at 25 pi, doesn't it? Okay, so this is, again, is our distance, okay, in terms of inches, okay? And then this is our height in terms of inches, okay? So this is a comparison with height and distance. So this is my maximum. That's my minimum, okay? So that means if you think about it, right, the middle of this, the midline would have to be at 12.5, wouldn't it? Okay, so my midline is 12.5, which means my D value is 12.5. And therefore my amplitude, right, would also be 12.5, wouldn't it? So that's my A, all right? So now if I connect my points, I end up getting a cosine again, okay? However, it looks a little bit weird because hopefully you can recognize that we're starting at a minimum instead of a maximum. So when I go to write my equation, I'm gonna do y equals 12.5 as my A value, okay? But my A value is going to be negative because of the reflection, and I'm starting at a min. Then it's cosine. I'm gonna do my B in a minute. Did I shift this at all? No, I did not, because I started at 0. So therefore, this is just x or theta, whatever you want to use, okay? And then this should be plus 12.5. And then my B value, well, what did we say our period was? Well, it's 25 pi, right? That's the total distance it will travel. So if I have to find B, I should say, 2 pi over B equals 25 pi. Okay, so 25 pi. Then I cross multiply, 2 pi equals 25 pi B. Divide by 25 pi, the pi's will cancel, so really it's 2 over 25 equals B. Okay. Now, I would probably change this and just put the whole expression. There's no shift, so I would, for our calculator purposes, right, put 2 over 25 inside the parentheses, and that is our equation, okay? Now, I ask you a couple questions on this one, okay? What I'm asking is find the first interval of time that the pebble is 15 or more inches above the ground, okay? So that will happen, the interval, right? So I want all the time here. So that should happen somewhere around here, shouldn't it? So this is where we're going to do and find our intersection of those two. So we have to use the calculator for this. So we've been practicing using the calculator to find values. Now we're gonna work on actually graphing with it, okay? So you're gonna go to y equals, okay? You're gonna put in negative 12.5. Cosine, make sure you're in radian. You probably haven't changed it, so you should be fine, okay? Then I'm gonna put the 2 divided by 25 in parentheses, and then multiply that by x. If there was a shift, I would put the plus or minus there. Close my parentheses. I should always have a double parentheses, the beginning and end, okay? And then plus 12.5, okay? That's my graph. Now I'm going to want to see, remember, where it intersects this line, y equals 15. So that's going to go in my y2, all right? Now, I already have my wonderful mins and maxes and everything here. So if you take a look, I want this graph to go from 0 to 25 pi, okay? Now remember, pi is like 3.14. So this is like 75 about, right? Maybe a little bit more. So when I go to my x-axis, I'm gonna make this maybe an 80, okay? You could also put in like maybe 28 pi and set it to be a number, okay? I'm just gonna go to my window, make my x, okay, a -2 because my graph starts at 0, so I made it a little bit smaller than that. My x max, you could make this a little bit more than 25 pi, let's say 26 pi, and literally put that in there, that's fine. Or you could put in like 80, okay, because this is, again, 75. 25 times 3.14, so a little more than 75, so I would go to 80, so you could put 80 there as well. It's up to you. See how it changed it automatically to 81, okay, so 80 or that 81. Then -2 for my y values, because I really don't need to go down below, okay, because the minimum always hits at a y value of 0. And then my y max, let's say, I'm going to go a little bit above 25, so let's say maybe 28, okay? Then if I hit graph, oh, look at that. Isn't that nice? Does it look just like ours? Yes, it does. And there's my 2 intersection points. So I'm going to hit second, trace, okay, go to intersect. And then I'm just going to bring this guy close to my first intersection point and hit enter 3 times, 1, 2, 3. And that's not going to be a pretty number, but it happens at 22.15, comma, 15, okay. And then my other one, okay, you have to use the intersect button to find exactly, because your table won't tell you this, right? An exact y value. So let's go back over here. 1, 2, 3. And we got 56.39 if I round, comma 15. Okay. And then it says for the first interval, right? Now, technically I say first interval because this goes up and comes back down, and then it travels another 25 pi. So this would be 15 inches above the ground on a second interval, right? The second time the wheel goes around, and then the third time the wheel goes around. So I'm just looking for the first time, okay? So I'm gonna take 56.39, okay, and subtract 22.15, because that's the distance, right, between the two, okay? So let's get out of this. So 56.39 minus 22.15, right? And that happens for 24 inches, right? Because these are, remember, distances, okay? Because x's are distances. For 34.24 inches, we are 15 inches at 15 inches or more above the ground. Now notice this one I ask you for what percent. Now, if this is a sinusoidal, right, the same thing happens all the time. So if I'm above the ground for this amount, right, of inches, then if I want a percent, don't I just do 34.24 inches out of the total cycle that I would have here, which would be 25 pi, okay? So you're comparing the amount compared to the whole period, and that would give you what would happen all the time because it's a periodic function. So now if I take that divided by, now be careful, you need 25 pi in parentheses because the calculator has to multiply those two first. Hit enter and there's your percent, 43. So this would give you 40.4359. So that's about 43.6%, okay? So that's how the percent of time, right, compared to the total cycle, that would be 15 or more inches above the ground, okay? So try the homework, okay? Again, look at the answer key to help you. And shoot me some emails if you have any questions, and I will see you guys soon.